this goodness of fit test, it will just tell us whether the sample, whatever we have collected from the entire population, whether it is a representation of the entire population. The goodness of fit tests are commonly used to test for the normality of the residuals or to determine whether the two samples are gathered from identical distributions. When we use the term dependence and interdependence, we are referring to different types of relationships within the given data. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session 7 of Unit 5, we will be having some more discussions on understanding the goodness of fit. Now, what do we mean by goodness of fit tests? So, goodness of fit tests are statistical methods that make inferences about observed values. For instance, you can determine whether a sample group is truly representative of the entire population. So, this goodness of fit test, it will just tell us whether the sample, whatever we have collected from the entire population, whether it is a representation of the entire population. As such, they determine how actual values are related to the predicted values in a model. Now, we have the set of expected values or the predicted values and the actual values. Now, these tests, they will help us to know what is the relationship between these two. What is the predicted value and what is the actual value. When used in decision making, the goodness of fit tests make it easier to predict trends and patterns in the future. So, with the help of this, so when they explain the relationship between the predicted and the actual values, with the help of this, we will be able to just predict the future patterns in the future. So, whatever is the trend in the future. So, this goodness of fit, they help us in the predictions for the future. Then, as noted above, there are several types of goodness of fit tests. They include the chi-square test, which is the most common, as well as the Kolmogorov-Smirnov test and the Shapiro-Wilk test. The tests are normally conducted using computer software, but statisticians can do these tests using formulas that are tailored to the specific type of test. So, this goodness of fit test, there are more than 3 types. Now, in this, we have the chi-square test, which is the most common one. Second one is the Kolmogorov-Smirnov test, and third one is the Shapiro-Wilk test. So, these tests are normally conducted using the computer software, but statisticians can do this test using formulas that are tailored for the specific type of test. So, almost all these tests we can do with the help of the computer software. Then, to conduct the test, you need a certain variable along with an assumption of how it is distributed. You also need to have a data set with clear and explicit values such as the observed values which are derived from the actual data set, the expected values which are taken from the assumptions made, and the total number of categories in the set. So, in order to have the goodness of fit test, we need to have certain types of variables. So, what are the different types of variables we need? So, in this, the first one is we need to have the observed values. So, what are the observed values which we have taken from the actual data test? Second one is the expected values. So, what are the expectations from the researcher about those values? And lastly, we need the number of categories in the set. What is the number of categories in each set? So, with the help of these 3 variables, we will be able to conduct the goodness of fit test. Next, the goodness of fit tests are commonly used to test for the normality of the residuals or to determine whether the two samples are gathered from identical distributions. So, when you are having different types of samples, so we can establish with the help of the goodness of fit test that these samples are coming from identical populations. So, from identical distributions. Now, what do we mean by distribution? We have the different types of distribution. We have the normal distribution, we have the skewed distribution, etc. So, we will be able to identify whether the samples are from the identical distributions. Then, special considerations. In order to interpret a goodness of fit test, it is important for statisticians to establish an alpha level, such as the p-value for the chi-square test. Now, they have to establish a alpha level or the p-value for the chi-square test, that is setting the standards. The p-value refers to the probability of the getting results close to the extremes of the observed results. So, this assumes that the null hypothesis is correct. A null hypothesis asserts that there is no relationship that exists between the variables, and the alternative hypothesis assumes that a relationship exists. So, in order to just test the null hypothesis, now what is a null hypothesis? A null hypothesis tells us that there is no relationship between the two given variables. When two sets of variables are given to the researcher, he comes to a conclusion. So, what is the conclusion? That conclusion is the hypothesis. Now, what is null hypothesis? With the help of this null hypothesis, we can prove that there is a relationship or there is no relationship between the two given variables. Now, in the null hypothesis, it tells us that there is no relationship that exists between the variables, whereas the alternative hypothesis, it tells us that there is a relationship between the two variables. Now, in order to test this null hypothesis and the alternate hypothesis, we need the goodness of fit test. Now, this goodness of fit test, in order to do this, first thing is we have to establish the p-value. Now, what is the p-value? P-value is the probability of the results getting close to the extremes of the observed values. So, what is the highest observed value? So, that will be considered as the p-value. So, with the help of all this, we will be able to establish the null hypothesis. Then, instead, the frequency of the observed values is measured and subsequently used with the expected values and the degree of freedom to calculate the chi-square test. So, that is the observed values with the highest frequency, they will be considered and they will be measured and used with the expected values and the degree of freedom to calculate the chi-square. If the result is lower than alpha, then the null hypothesis is invalid, indicating a relationship between the two variables. Now, if the null hypothesis, that is if the result whatever you are getting, that is the goodness of fit test. So, if the result is lower than alpha, that alpha is the p-value. If the result is lower than alpha, then the null hypothesis is invalid. So, we can say that the null hypothesis is not correct. Then we can say that there exists a relationship between the variables. Then next is the chi-square test. The chi-square test, which is also known as the chi-square test for independence, is an inferential statistics method that tests the validity of a claim made about a population based on a random sample. So, the chi-square test, so it is an inferential statistical method. So, it is a statistical method with this help of which we can say that the validity of a claim made about the population. So, we can say with the help of the chi-square about the validity of the population. Then, used exclusively for data that is separated into classes, it requires a sufficient sample size to produce the accurate result. Now, the chi-square test, it requires a sufficiently large sample size to give good results, but it doesn't indicate the type of intensity of the relationship. For instance, it does not conclude whether the relationship is positive or negative. Now, with the help of the chi-square test, we will be able to establish that there exists a relationship between the two variables, but then it does not tell us about the intensity. What is the amount of relationship? It will not tell, or it will not tell whether there is a positive relation or a negative correlation existing between the variables. Then, next one is to calculate the chi-square goodness of fit, set the desired alpha level of significance. So, if your confidence level is 95% or 0.95, then the alpha is 0.05. Next, identify the categorical variables to test, then define the hypothesis statements about the relationship between them. So, in order to calculate the chi-square test, first thing is we have to have the confidence level. So, if the confidence level is 95%, that is, if the researcher is sure that there is a relationship between the two variables, or there is no relationship between the given two variables, and he is having a 95% sure about it, or 0.095, then the alpha level will be 0.05. So, next we will be identifying the categorical variables and then define the hypothesis statement about the relationship between them. The variables must be mutually exclusive in order to qualify for the chi-square test for independence, and it should not be used for data that is continuous. So, this chi-square test, it cannot be used for data that is continuous. Next, what is multivariate analysis? The next important concept is the multivariate analysis. Now, what do you mean by multivariate analysis? So, in data analytics, we look at different variables or factors and how they may impact certain situations or outcomes. So, there are multiple factors which will affect the variables. So, what are they? For example, in marketing, you may look at how the variable money spent on advertising impacts the variable, the number of sales. Now, here we have an example here. So, that is the advertisement expenditure and how it is having an impact on the sales of the product. So, when you have a comparison between these two variables, so we will be able to know the greater you spend on advertising, the higher will be the sales of the product. So, in the healthcare sector, you may want to explore whether there is a correlation between weekly hours of exercise and the cholesterol level. So, suppose you take the example of the healthcare sector. So, how many weekly hours you are exercising? Hours of exercise along with the cholesterol level. So, if you have a comparison between the two, so we will be able to understand and why certain outcomes occur, which in turn allows us to make informed predictions and decisions for the future. So, with the help of these weekly hours of exercise and the cholesterol level, so we will, if we find that there is a relationship between the two, then we can come to a conclusion that these many hours of exercise will help us in preventing the cholesterol level of each of the individuals. Next, there are three categories of analysis to be aware of. So, in the multivariate analysis, we have three categories. What are the three? First one is the univariate analysis, which looks at only one variable. So, the univariate analysis looks at the only one variable, whereas the bivariate analysis, it analyzes two variables. Third one is the multivariate analysis, which looks at more than two variables. So we have the univariate analysis, bivariate analysis, multivariate analysis. Now, when we have these three types of analysis, we will be able to just understand what is multivariate analysis. Now, as you can see, multivariate analysis encompasses all statistical techniques that are used to analyze more than two variables at once. So, this multivariate analysis, it will help us in analyzing more than two variables and simultaneously. The aim is to find patterns and correlations between several variables simultaneously, allowing for a much deeper, more complex understanding of a given scenario than you will get with the bivariate analysis. Now, what is bivariate analysis? It is an analysis of only two variables, whereas a multivariate analysis is an analysis of more than two variables. Now, when we are having an analysis of more than two variables simultaneously, we will be able to assess the impact of these variables in a much deeper way. We will be going deeper into the study of these variables, and we will have a more complex understanding of the given scenario. So, whatever is the scenario given, so how the three variables are impacting them, so we can have a deeper study of the impact of the three variables on the given scenario. So, this is possible only with the help of the multivariate analysis. Then, an example of multivariate analysis. So, let's imagine you are interested in the relationship between the person's social media habits and their self-esteem. You can carry out a bivariate analysis comparing the following two variables. Now, in a bivariate analysis, now we have the person's social media habits. So, how long he will be interested in the social media and his self-esteem. So, when you are having two variables here, so how it will be impacting each other, we will be able to know. So, how many hours a day a person spends on the Instagram? So, what is the number of hours he spends on the Instagram, and then their self-esteem score. So, this we will be able. So, if you can see this table here, so hours spent on Instagram per day versus the self-esteem score. So, if you can see here in the x-axis, we have the self-esteem score. So, the self-esteem of 20, 40, 60, 80 and 100, and here the hours spent per day on the Instagram. So, we have 2, 4, 6, 8, 10 hours. So, if he is spending almost 10 hours in the Instagram, that means his self-esteem score is just 20. Now, if he is scoring around 9 hours on the Instagram, that means his self-esteem score is around 30. So, if we can just analyze in this way, so a person with a high self-esteem, that is 100, so he will be spending 0 hours on the Instagram. So that means a person with a lower self-esteem, he will be just more and more involved in the social media, whereas a person with a high self-esteem, he will not be connected so much to the mobiles, or he will not involve himself more with the social media. Then, an example of multivariate analysis. So, you may or may not find a relationship between the two variables. However, you know that in reality, self-esteem is a complex concept. It's likely impacted by different factors, not just how many hours a person spends on the Instagram. Now, we know that this self-esteem is something which is not directly dependent on the number of hours a person spends on the Instagram. So, you might also want to consider factors such as age, employment status, how often a person exercises, and the relationship status. So, in order to deduce the extent to which each of these variables correlate with self-esteem, and with each other, we need to run a multivariate analysis. Now, the self-esteem is something on which, so there are so many factors which decide the self-esteem of the person. So what are the factors here? So the age factor is there. Then we have the employment status. So if he is very good, very well employed, then his self-esteem will be nice. Then how often he is exercising. Then and the relationship status. What is the relationship status, etc. So all these factors will influence the self-esteem of the person, not only the social media. So the social media is just one aspect of the person's characteristic. So there are so many other factors which will be affecting the self-esteem of the person, and to analyze the impact of all this on the self-esteem, we need to have a multivariate analysis. There are so many variables here. So we have to see what is the impact of all these variables on the self-esteem of the particular person. So in order to analyze that, we need multivariate analysis. So we know that multivariate analysis is used when you want to explore more than two variables at once. Now let us consider some of the different techniques you might use to do this. So there are different techniques through which we will be able to have this multivariate analysis. Now what are the various techniques? So there are different techniques for multivariate analysis. They can be divided into two categories. In this, the first one is the dependence techniques. Second one is the interdependence techniques. Now, what is the dependence technique and what is the interdependence technique? So, what is the difference? Let's take a look. So, when we use the term dependence and interdependence, we are referring to different types of relationships within the given data. So, what are the different types of relationships within the given data? Let us see. So, in the next session, we will be able to see what is the different types of relationships existing between the variables. With this, we come to the end of this session. Hope you have all followed it. Thank you.